Hello, this is Group 9, and today we are going to walk through the explanation of the code and the GUI visualization of the implementation for Coding Project 2 under the course Computational Geometry CSL 523 taken by Professor Sudeep Roy. This is the problem statement assigned to Group 9, where we create a single massive super triangle that encloses all n inputs to start the process, and then shuffle the entire input set into random order, then select the next point P from this shuffle list, and then search for the current triangulation T to find the specific triangle that contains the new point. uh, Now remove the triangle and replace it by splitting into three new triangles, and recursively we check for the adjacent edges and flip any edges that are illegal, meaning that a point lies inside its neighbor circumcircle. And this main loop repeats the insertion steps 2 to 5 from the random list that have been added. This is the implemented code. Here we have the headers. These lines identify our group members, project title, and the problem statement. Followed by we have the imports, where we import the necessary libraries, for example tkinter for GUI, random and math default dictionary. These are the imports. Next we have the geometry utilities, where the orientation ABC, which represents a math test to check if a point is to the left or right or on the line segment AB. And then we have point in triangle. We have the circumcenter ABC, which calculates the exact coordinate of the center of the circle that passes through the 3 points. And we have dist to A comma B, and then we have in circumcircle ABCD, where the most important geometric test, it uses circumcenter and dist to check if point D is inside the circumcircle of triangle ABC. This is the core of Delano legalized step. Next we have normalize V, and then clip rate box. So basically in this small function we calculate the intersection point where an infinite Voronoi ray hits the edge of the canvas, so it can be drawn. Next we have the RAC class, the algorithm engine. In this class it contains all the logic and data for the randomized incremental construction algorithm. So first we have init and reset. These initialize the algorithm, and they create a massive super triangle that encloses all endpoints and sets the initial triangulation. And then we have prepare random order followed by local containing triangle index, and then we have insert point by index, and this is the main function that performs algorithm steps 4 and 5 as mentioned previously. It first calls locate, and then step 3 further then subdivides the whole triangle into three new triangles, and finally runs the while edges to check, which perform the looping for edge flipping until the Delano condition is restored. And then we have finalized triangle followed by compute Voronoi. So in this function, this determines the final Voronoi diagram. It uses the dual property by finding the circumcenter of every Delano triangle and connecting them to the Voronoi edges. Followed by we have final tris cache and setup. And then we have the app class for GUI and animation of the implementation. Similarly, we have the init and set n, which is basically a drop down box for where we can set the number of nodes as per the user's interest. And then we have reset triangulation, clear all, generate random. So basically in this generate random we implement the problem statements requirement to randomly generate the n distinct points. It loops n times, creating random coordinates and adding them to self points. And we have on click start RAC. So in this start RAC animate button, um, we have the main go function that initializes the RAC object, prepares the random order, and starts the animation. And later on we have root after insert, draw partial, and draw self. In this draw self, which is the main drawing function, It draws the final diagram respecting the user's choice from the buttons delete, overlay or combine. So lastly we have the main function. This is the standard Python enter point that runs when you execute the script. It creates the main tk enter window, and where it creates an instance of our app class and starts the program's main loop. This is the GUI visualization of our implementation. Here I am selecting n to be 10. After I have set this n, now I am generating the random endpoints manually. Whenever I click on this given 2D display, I can generate a point. So in total I will be generating 10 points. Now I am clicking this start RSA animate function. This basically creates the whole Delano triangulation of our selected points. Here in these three options checkbox, we can click visualize the Delano triangulation. We can visualize this Voronoi diagram, as well as we can combinedly visualize the Delano triangulation and Voronoi diagram. Now let's go through the second example where I am setting n to be 20. Once I set the n value, now I am generating 20 random points in this 2D space provided. After I have clicked this start RSA animate, where the Delano triangulation is formulated. Now once the Delano triangulation is formulated, when I click this checkbox for Delano, the whole Delano triangulation could be seen, and then when I click the checkbox for Voronoi, again the Voronoi diagram is shown, and you can also visualize the combined Delano triangulation and Voronoi diagram. These are the extra features that we have implemented in our project. The first one is live RAC, where the live transformation of the generated random points to the Delano triangulation is formulated and is visualized. And the second extra feature is the 2D space, where we can randomly generate the point on the click, on the right click. And the third extra feature is the combined visualization of the Voronoi as well as the Delano triangulation.